In this video, we're going to work example problems related to the inverse trig functions. All right, for these first problems, we want to find the exact value of each real number y if it exists. So yeah, this terminology, real number y, that's kind of, it's related to the way they talk about it. It's because they're talking about circular functions, but again, in this course, we're not getting bogged down with the circular function terminology. What we're doing is just, when we think circular function, we're just thinking trig function in radians, even though that's technically not exactly what a circular function means or is, but that's the way we're going to think about it. So they're making this distinction because, remember, it can be confusing, but with an inverse trig function, the input here is not an angle, the output is an angle. We're asking, when you take the sine of some angle, you get 0. Well, what is that angle? We know the sine of some angle is 0. Okay, so what we do, but we want to know what that angle is, so we input that 0 into the inverse sine function. And what comes out is an angle, but they're saying real number, not an angle. And, you know, that's, I would tend to say that a radian is a real number because it's unitless, but based on the definition of circular functions, technically even a radian is not it's still like an angle. So if you're confused about that, go watch when we talk about in chapter 3 circular functions. But we're thinking about what angle is this. When you take the sine of this angle, you get 0. What angle is that in degrees or radians? That's the way we're going to look at these problems, or any unit you want. So, okay, based on the definition of the inverse sine function, the way it works is the inputs, the domain of inverse sine is just the full range of the sine function. So anything between -1 and 1, because that's the idea. Anything that you could possibly get as an output from a sine of you take the sine of an angle. What are all the possible outputs you can get? Well, it's from -1 to 1. Well, that's what you can input into the inverse sine to ask the question. I took the sine of some angle and got this value, so it's going to be something between -1 and 1. So what is the angle? Okay, now, but the potential angles are infinite because sine is periodic, and so it could be, there's like infinite number of coterminal angles, but then it's even more than that. So if this is we're going to get a quadrantal angle here. So yeah, let's just do this first. So we're going to get a quadrantal angle here, but if it's not a quadrantal angle, then there's actually 2 separate angles between 0 and 360 that will satisfy the criteria of the inverse. And so you have like all of those 2 angles, and then every angle that's coterminal with those 2 angles. So there's an infinite number for inverses like this. There's an infinite number of actual angles that satisfy the question being asked by the inverse. And that's why for the definition of the inverse trig functions, the domain is restricted to where we're only going to, this is going to give us an angle between -pi/2 and pi/2. And so if you restrict it in that sense, there's only going to be one angle between -pi/2 and pi/2, where when you take the sine of that angle, you get 0. Okay? And so that's the way we think about it. So what angle is that? Well, sine is y over hypotenuse. Well, that's going to be when theta is equal to 0. So this is 0 degrees or 0 radians, however you want to put it. Okay. Now, same idea with inverse cosine, except the domain is restricted to the angles that it's going to give us. It's going to be something between 0 and pi in the case of inverse cosine. So we input -1 to inverse cosine, and so there's only one angle between 0 and pi where when you take the cosine of that angle, you get -1. And that's going to be actually another quadrantal angle. That's going to be 180, or we'll do it in radians. So that would be pi. Okay, and you know, just to note, there's other angles to where, so if you plugged in 3 pi, if you said cosine of 3 pi, what do you get? You get -1. So is 3 pi an answer here? No. this is absolutely not equal to 3 pi. Even though when you take the cosine of 3 pi, you do get minus 1. This is incorrect. This is not equal to 3 pi. And because that's the definition of the, if this could be equal to 3 pi as well, well, then the inverse cosine wouldn't be a function, because you'd have the same input mapping to multiple outputs. So to make it a function, we restricted the domain of the cosine function to create a one-to-one function to where we could get an inverse function. So it's only equal to pi. Okay, inverse tangent of 1. So what angle, when you take the tangent of that angle, do you get 1? Okay, now with inverse tangent, the domain of tangent was restricted to create the inverse function to between minus pi over 2 and pi over 2. So the angle is going to be between minus pi over 2 and pi over 2. So the question is, what angle between minus pi over 2 and pi over 2, when you take the tangent of that angle, do you get 1? There's going to be only one angle in that range. So we know tangent is negative in quadrant 4, positive in quadrant 1. So this angle is going to be in quadrant 1. And the ratio is 1 over 1. So this is going to be a 45-degree angle. You know, we think about the reference triangle, 45, 45, 90 triangle. It's 1, 1, root 2. Okay, so the answer here is, convert this to radians, so the answer is pi over 4, and that's the only answer. Okay, arc tangent of 0, we know that this arc terminology here, this is just another way of writing the inverse. Okay, so what angle, and this is going to be between minus pi over 2 and pi over 2, when you take the tangent of that angle, do you get 0? Well, that's going to be 0 degrees. So this is going to be, or 0 radians. Now, with quadrantal angles, there's not going to be another angle from 0 to 360 to where you take its tangent, you get 0. So thinking about this in the big picture, it's going to we're just going to say that what answers this question is 0 degrees or any angle coterminal with that, and that's it. It's only for non-quadrantal angles where there's going to be some other angle in the plane that satisfies the criteria as well. All right. Arc sine, we know that's the same thing as just saying this. Okay, so with sine, the question is, the range of sine is minus pi over 2 to pi over 2. So the question is, what angle between minus pi over 2 and pi over 2. It's important that you state that. That's what the inverse means. What angle between minus pi over 2 and pi over 2 is it to where when you take its sine, you get minus root 3 over 2? And because of that angle restriction, there's going to be just one and only one angle where this is true. There's only one angle between minus pi over 2 and pi over 2 where when you take the sine of that angle, you get minus root 3 over 2. Okay. Now, this ratio here, does this correspond to the 30, 60, 90 or 45, 45, 90 triangle? Yeah, so let's draw the 30, 60, 90 triangle. So we've got 1, root 3, 2. So root 3 over 2 is okay, so no, it would be root 3 over 2 is sine 60. Okay, but we know that sine is positive in quadrant 1, negative in quadrant 2. So let's draw a 60-degree reference angle in quadrant 2. Okay. So, and note, you can, again, with these inverse trig functions, you could work in radians, degrees. It's all based on the general definition of trig functions, which is just based on angles, regardless of the units. So, okay, so 60, 30. So here, this is positive 1. This is negative root 3, and this is positive 2. So this angle is, and yeah, remember, it's tempting to, I almost did this. I almost drew the angle like that. And, so that angle, whatever this is, that would be what? 300 degrees. So this angle, the sine of 300 degrees is minus root 3 over 2, which is, that is true, but that's not going to be the answer here. This is not equal to 300 degrees. Absolutely not. It's you look at it from the definition of inverse sine is, we look at it from this perspective. That's minus 60. So I'll do it in radians. 60, 180 degrees, pi radians. So pi over 3. So this is equal to minus pi over 3. Okay, arc cosine, let's see, of minus root 3 over 2. So, all right, we're going to use the 30, 60, 90 triangle again. Okay, so now cosine, or arc cosine, it's going to give us an angle between 0 and pi. There's going to be one angle between 0 and pi where when you take its cosine, you get minus root 3 over 2. Okay, we know cosine is negative in quadrant 2, positive quadrant 1, so the angle is going to be somewhere in quadrant 2. And let's see, so root 3, 30 degrees, with reference angle 30 degrees, adjacent over hypotenuse. So let's draw a reference angle of 30 degrees. So there we go, 30, 60. So 1, this is minus root 3, 2. Okay, now in this case, actually, this is the angle because it's between 0 and pi. And so that's what? That's 150 degrees. So let's see, so 150. I mean, I'll keep converting it to radians, but you could absolutely say this is completely correct as well. Now, not according to this question here, they're saying real number, so they're wanting us, they wouldn't want us to put it with degrees, but we're not thinking about this. So this is completely valid here. 150 degrees. And that's between 0 and 180. So that's within the range of arc cosine function. Okay, arc sine root 3, that's the angle is going to be between minus pi over 2 and pi over 2. So it looks like we can use the 30, 60, 90 triangle again here. Okay, so 1 root 3, 2. And just to point out, I'm not sure, I don't think in this video or maybe even in the any of the upcoming videos with example problems on inverse trig functions, we're not going to actually do any problems that we can't manually get the value ourselves. Like if this was root 5, well, there's no reference triangle that we can draw that would allow us to figure out an angle corresponding to like root 5 over 1. So what do you do in that case? Well, that's what the calculator's for. That's what, in that case, we would do. So you could do arc sine of root 5. Oh, well, that's greater than 1. So, okay, yeah, you would do arc sine of, whatever. So 0.85. And there you go, 58.2117 degrees. You just need to make sure you understand the meaning of it. The meaning is the meaning of arc sine of 0.85. So root 5 is outside of the domain because it's greater than 1. But the meaning of arc sine of 0.85 is the exact same as what I've been talking about this entire video. Exact same. Exact same. It's what angle, when you take its sine, do you get 0.85? But, well, let me restate that. It's what angle between minus pi over 2 and pi over 2, or between minus 90 and 90, when you take its sine, do you get 0.85? And that is 58.2117 degrees. And then you could, in the same way, you can think about, okay, in another quadrant, what is that has the same, it's positive or negative, the same positive or negative that you're dealing with has reference angle 58.2117. So yeah, I actually might make a separate video just to make it clear that everything we're doing in this video and other videos where we actually are using these reference triangles, you can do that with, even if you can't get the exact value, you could use your calculator. It's the same thing. So yeah, I'll make a separate video on that. But okay, so sine, this is positive. Sine is positive in quadrant 1, negative in quadrant 2. So we're in quadrant 1. Let's see. So root 3 over 1. Well, okay, here this is an example where we can't get the exact value because you can't get, sine of 60, tangent of 60 is root 3, cotangent of 30 is root 3, but that's the only way you can get root 3. And with the 45, 45, 90, that contains it's 2 1s and a root 2. That's not going to do anything. So here, the sine of some angle is root 3 over 1. Root 3 is greater than 1, so it's going to be greater than 45, a little bit greater than 45, but it's going to be greater than 45 because you have opposite over, well, no, okay, is it going to be greater than 45? Oh, wait. No, okay, this doesn't make any sense. This is no solution. No solution. Root 3 is greater than 1. And that makes, and I realized that because how could you have a sine be greater than 1? The opposite over the hypotenuse is root 3. That doesn't make any sense. The hypotenuse is always bigger than the leg, so there's no solution here. Root 3 is greater than 1. That's outside of the domain of inverse sine. Okay, inverse cotangent of minus 1, so we know with the 45, 45, 90, we got 1, 1, root 2. So, okay, with cotangent, the question is, it's between what angle, not between minus pi over 2 and pi over 2 like tangent, but what angle between 0 and pi, when you take its cotangent, you get minus 1. And so we're going to be in quadrant 2, and it's going to be a 45-degree reference angle, because at 45-degree reference angle, the two sides have the same length. So you're going to have, this will be like a 1 and minus 1. So 135 degrees. Okay, cosecant. Is this within the range or the domain of cosecant? Yes. Anything from minus 1 to minus infinity or 1 to infinity. So, okay. We've got, let's see, the 30, 60, 90 triangle has a 2 in it. So 1 root 3, 2. Hypotenuse over adjacent is what of 60? So that's secant of 60. hypotenuse over opposite, that's cosecant. So this would be cosecant of 30 is 2. So, but we've got negative 2. So cosecant, the way it's restricted is it's okay. So what angle, when you take its cosecant, what angle between minus pi over 2 and pi over 2, but 0 not included because that's associated with the vertical asymptote. So it's what angle between minus pi over 2 and pi over 2, not including 0, when you don't even have to say that really, because you could just say, okay, what angle between minus pi over 2 and pi over 2, when you take its cosecant, do you get minus 2? That's really all you need to say. But you're never going to get 0, though, I guess, is something to remember. So, okay, but cosecant's going to be negative in quadrant 4. Let's draw a 30-degree reference angle. Okay, 30. So we've got root 3 minus 1, 2. So therefore, the cosecant of 30 is minus 2. Well, no, the cosecant of minus 30. So, okay, let's actually put this in. Let's do radians this time. So 180 degrees, pi radians. So minus pi over 6. Okay, arc secant, this is, so there's 2 root 3 over 3. That is 2 over root 3. But once you rationalize it, you get 2 root 3 over 3. So let's see, that should something to do with 30, 60, 90. Okay, so 2 over root 3, that's hypotenuse. Okay, so that would be secant is the reciprocal of cosine, so adjacent, that would be, secant of 30 is 2 over root 3. So, okay. So secant is going to be positive in quadrants 1 and 4, but the definition of arc secant is we're going to be looking for an angle between 0 and pi. So we're going to be in quadrant 1 then. So let's see, we've got this 30, 60, 90, so it's going to be reference angle 30 in quadrant 1. So 30, 60. So there we go. Secant of 30 is 2 over root 3, which is 2 root 3 over 3. 30 this is pi over 6. Okay, secant of, or arc secant of 1, so but something between 0 and pi, we will, oh, is that within the domain of arc secant? Yes. So, okay, we can think about a 45, 45, 90. Okay, so, well, no, this is going to be a quadrantal angle. This is going to be, this is where, because hypotenuse over adjacent is going to be equal to 1. That's where at theta is equal to 0, the radius equals to the x value in the positive direction. So this is going to be equal to 0. All right, cosecant. So an angle minus pi over 2 to pi over 2, where you take the cosecant and you get root 2 over 2, which is also, the root 2 over 2 is 1 over root 2, just rationalized. So 1, 1, root 2. So, Okay, cosecant is going to be positive in quadrant 1, so we're going to have a, let's see, it's going to be 45 degrees. 1 root 2 opposite over hypotenuse, so hypotenuse over opposite is cosecant, so that's root, or no, wait, is this might be outside the domain of cosecant. 1 over root 2, yeah, it does not exist. This is outside of the, there is no, you can't get cosecant 1 over root 2. Cosecant of an angle is never equal to 1 over root 2, so this does not exist. The domain of cosecant is something between something from 1 to infinity or from -1 to minus infinity. This is like 0.7 something, so there's no solution here, or does not exist.